All right, before we announce the first segment today, just a note, if you're going to come up to one of the mics on the floor to ask a question, you got to eat the mic. It's got to be right by your face. Those are really low, so people online are having a problem hearing. I always even have a problem hearing just here in the house. So if you're on one of these mics, get it right there into your face. All right, first up today, with Bad BCI Good FCI, we have Steve DeRochers from Alpha, and I love your title, the Chief Innovation and Analytics Officer. I love that title. All right, take it away, Steve. Well, please welcome Steve.
Kurt for me being up here because 10 years ago, almost to the day, he taught me about Builder. So thanks, Kurt. And it's awkward being up here this year because there's no Ishmael, and Joe now works with us. So Joe has seen all the slides and has helped. So I'm not sure where to look for the questions. So I'll really be on a swivel today. Yes, he will. So what am I going to talk about today? So I'll tell you why in a minute. First, I'm trying to find some visuals that will help us explain FCI, BCI, and how they relate together. Okay, so that was one mission. And then I want to use those visuals to go in and say what combinations of BCI and FCI can you expect in a normal building? Are things normal or abnormal? And I'll discuss what I mean by normal in a little while. So, visuals, part one. So, FCI is really easy to explain using just words. But have you ever tried to explain BCI to somebody? So, all you do is you got these CSCIs, and then you multiply them by their CRVs, and then you do this weighted average, and yeah, by the time you get that part, you're looking just like this guy here, right? And then you say, and he goes, well, how does that relate to FCI? Well, you're like, well, and then they lose, right? You're gone. So that's why we're trying to find something. So go back here. So where it really came into important, a couple years ago, the POM planning cycle, which is a DoD planning thing, used to be based on FCI. And one of the things you had to figure out was whether or not a building was failing according to a KPI. In the old days, it was FCI. Well, 2 years ago, they switched to BCI, right? And one of our clients now is like, okay, we've explained FCI to our upper executives, and now I've got to explain BCI, so help. How can we explain BCI to a senior executive who doesn't get the chance to come into this great conference and learn what BCI and FCI is? So that started a 2-year odyssey where we were jousting with windmills trying to find some good graphics. So this is the genesis of what we're doing right here. So everybody knows FCI, or if there might be a few new people in the audience that don't. It's essentially what percent of your PRV doesn't need to be replaced. And that metric works best when the CRV, the inventory, matches the PRV. But a lot of you, and so we created a visual. I got a little ahead of myself. So we thought this would be a good visual, so we used a balance scale. So on the right side of the scale, you put in a coin that represents the PRV, and on the left side of the scale, you put in the coins that represent work. And then in the middle, in our fancy dial, you can see what the FCI is. So as those red coins go down, so does your FCI, right? The more coins on the left side, you get that. And people seem to be pretty receptive to that image. However, if you belong to the DoD, this is a warning, and all of you know it now. The problem with the FCI and the DoD is the red coins, are based on your inventory and what part of the inventory needs to be replaced. The PRV is not based on the inventory. okay? The PRV is based on a parametric calculation. So it's easiest to explain with an example. If I had a building with a CRV of 100K and 10K of its inventory needed to be replaced, right? That's pretty simple. But in the DOD, the PRV of the building depends on what the FAT code is. Now, show of hands, who knows what the FAC is? Okay? It's, oh, by the way, if you raised your hand, you're out because I didn't say Simon Says. So, so the FAC is the Facility Analysis Code, and it's the code that's assigned to the building that, excuse me, that gives you a unit cost to calculate the PRV. It's $1 per square foot. So in this example I had, let's say we took that building with 100K CRV and we gave it one FAT code. The PRV may only add up to 50K, and now our PRV is at an 80. But if you pick the FAT code where the PRV was close to the CRV, your FCI jumps to a 90. And if you pick the FAT code where it was 200K, we now have a PRV of just 95. Now, how many, okay, no more Simon Says, how many people think that that's two extremes and that 50% and 100 and 200% are the extremes of what we see in the DOD inventory? Yeah. Not many, because it's way worse than that. I have seen 10% of PRV and 30 times the CRV. So that's really a problem in the DOD, and sometimes when we're doing analytics, we will do an inventory-based FCI. So, and that puts us in the middle category, and everything I'm gonna talk about today is with an inventory-based FCI where the PRV equals the CRV. Okay, fun fact, I know that's kind of an oxymoron when we're talking FCI and BCI, but fun fact about FCI, when the FCI is 80, it means the same thing for every building that has an FCI of 80. 20% of the PRV needs to be replaced. So the other thing in this presentation, we talked about good and bad. So I had to have a threshold for FCI. So I picked 80 because that's what the POM used to use for a good FCI. You can pick whatever value you want in your organization, but for today, we're going to say 80 is the good number. Now, BCI. This is tough. I hate explaining BCI, right? Even to the audience who knows it, right? So BCI is the average CSCI weighted by the replacement value, okay? Now, a building has about 100 sections, so you've got to take section 1 times its CSCI times its CRV, out to however many sections there are. And 100's an average, but it's not unlikely to have 300. I like math, and this makes my eyes roll and glaze over, right? So can we do something different? So the client I was talking about was Dodia, and we've been collaborating for a couple years, and a little while ago, Melody Will at Dodia said, what about grades? We're schools, so what if we can break this down somehow into grades? And that was pretty good. It started a thought process that I think we took and ran with. So I know I was showing this to my team, and Travis was like, everybody knows that equation. Like when we were in college, you had a final worth 40% and two tests worth 30%. And he goes, I was the kind of guy who, before that final, and he's like me, we would figure out what I needed to get on that final to pass, right? Now, there's two other types of populations out there. My older two kids either didn't care or didn't want to tell dad they cared, because when I showed them how to do this, they're like, yeah, dad, whatever, right? They didn't care. But my youngest was a little different. She wasn't trying to figure out the minimum she needed to pass. She wanted to know the minimum she needed to get an A, right? So she was very ambitious. So she used this, and she used to call me up and say, Dad, I only need an 85 to get an A, right? She's really excited. What if we could make BCI something that easy? So that's what we did, and we're going to show you guys, and you guys can be the judge on how well we succeeded or not. So we tried A, B, C, D, F. We tried A, B, C, D, E, and F, and what we came down is you can't take a school domain where the grades are based on 90%, 80%, and translate it to buildings. So what we did is we looked at the domain and what makes sense for buildings. So we looked at the life of a section in Builder. It starts out with an CSCI of 100, and as long as it's above whatever threshold you set, and I got 70 there, and I'll explain why, but as long as it's above that threshold, it's going to contribute to both a good BCI and a good FCI. So just like if you were in school, if you were trying to get a B and you needed an 80, a score of an 81 was going to help your grade, right? Score of 79 doesn't. So when you get below that BCI threshold, now your component section starts contributing to a bad BCI. Because if you get a 79 on the test, now you got to have something, you need an 81 score to balance it out. So that's where that amber region is. But remember, work doesn't start till a section has aged much greater. So it's got to get down into this red zone. And for today, I used a CSCI of 40, which I will explain in a couple slides. So at that point in time, now that section is expired, and it's below the BCI threshold. So now it's contributing to both a bad BCI and a bad FCI. So we thought that concept could work. So why did I choose 70? Well, it's actually 69.5. I cheated, right? Builder, that's when the BCI in Builder turns red, is at a 69.5. We could have also used a 60, which is what the POM used, and Bill showed us yesterday a 55.5 for the Air Force, which is actually halfway between a red plus of 50 and an amber minus of 61. Pretty sure that's where they got their 55.5. So for today, and your mileage may vary when you use your own thresholds, a CSCI above 70 is good. A CSCI below 70 is going to contribute to a bad BCI. Now, why did I choose 40 for the CSCI? Well, as you know, as soon as you put a rating in Builder, the curve I showed is the standard curve. And a lot of my training materials, a lot of Kurt's training materials, and a lot of the documents that are written in Cyril use that standard curve. But that's not what we have in Builder. I looked at one set of data, and we had 45,000 different, and I know that's not a lot. I'm jealous of Matt. He's got all those curves he can look at. We've got 45,000 curves for this one client, and I looked at their stuff, and there were over 15,000 individual curves. If you take 15,000 individual curves, the only point they have in common is when your CSCI is 40, because due to the Builder equation. And at that point in time, it's also where the RSL is 0. So if I picked an RSL threshold of a 1, I could not pick a single CSCI to go off of. It could be 42 to 48 or 52. And I've seen work generated when things are in the amber range, above the 55.5. So to make this simple and have a straight line, we use the CSCI of 40 as the work threshold. RSL is 0. So now how do I turn 100 or more CSCIs into 3 values? Well, you got to use a computer because nobody wants to do this by hand. So you take all your CSCIs and you group them up into 3 groups. The greens, the ones that help both, the amber, the ones that hurt BCI, and the red, which are the ones that hurt both. And you calculate 3 intermediate BCIs. And then we put them on this plot. We call it the balance beam plot. On the left-hand axis, your y-axis is what percent of the total CRV is your green, amber, or red, and the x-axis is what your score is, what that individual BCI is. Now, when you put some coins up there, you're going to get a balance point. So this will be familiar to all the mechanical engineers who took statics, and the rest of us are thankful that we were not mechanical engineers. Yuck. I'm a double E, so it was easier to deal with theoretical stuff than actual physical stuff. So we put the color scale there that matched what was up there on that builder curve. And so if I'm in the green, I've got a good BCI. If I'm in amber or red, my balance point, I have a bad BCI. Now, onto this beam, what we did is we placed coins, right? Because we want you to remember that your weight is based in dollars. What are the replacement costs of all those sections? So we've got our green coins stacked up in the green region, the yellow ones in the yellow, and the red ones in the red. Their score, their BCI, their intermediate BCI is shown in numbers on the beam, and their percent of the total CRV is shown above the coins. Now, to make it simple, and because you can't go to Excel and make a plot like this, for right now, we rounded the coins. 1 full coin is 20%, half a coin is 10%, and we rounded. And sometimes you may see 5.5 coins in our display, but when we get this programmed, it'll be, you'll have slivers of coins, so it'll be easier. So what does this look like for 4 real-world buildings that all have the same BCI? So in the upper left, we've got a building that's got 9% of the CRV with an average BCI for that group of 8. Now remember, a red minus is a 10. So you've got at least 9% of your sections down there that are lower than 10. And a red minus is, the way I think of it is, it's either failed, or if you came in tomorrow, you would expect it to, you would not be surprised if it was failed, right? So to me, that building has a chunk of equipment that is in bad shape. One thing you point out is it doesn't tell you what equipment. This could be interior finishes and no big deal, but it could also be your roof. So while in this particular case we can assume there's a lot of risk, we have no idea of what the consequences of that risk are. And one of the things to know about KPIs is to understand what they tell you and what they don't tell you, and don't make assumptions about what they don't tell you. So for a BCI 74 tells you nothing about how many sections are about to fail and what's the risk of failure. Now the bottom left and the upper right are a little bit better, I think, but the tricky one is the bottom right. Right now there is no work. That one's got a BCI of 74 and there's no coins in the red, so there's no work. Its FCI is 100. But when I see that, I get a little nervous because I got 50% of the CRV of my building getting really close to needing work. So one of the things to think about is to remember on both BCI and FCI, and I'll paraphrase Dylan, the winner today may be last tomorrow, right? So just because this is the situation today tomorrow, neither BCI or FCI tell you what's going to happen. You have to look at BCIs and FCIs in the future to see that. So I'm more worried about the lower right-hand building than really any of the other buildings, because I see a tidal wave coming for that building. Okay, so BCI fun fact, again, maybe an oxymoron. You got to remember BCI is an average. Just like if you have an 80 average in school, you can't tell whether you got all your grades were an 80 or half your grades were 100 and the other half of the grades were 60. It's the same. Okay, so if I put the two plots together, I can show you the one way that BCI and FCI are related. The only thing that makes them related at all is if you pull the red coin off your balance scale and put it on your, the balance beam and put it on the balance scale, that's how they're related. That's it. So you notice BCI doesn't care what the CRV is. Okay? FCI doesn't care whether your other coins are in yellow or green, where they are, it doesn't care. So, and again, both of them, you can't tell what sections of your building are fixing to fail, if any, and what the consequences of them failing are. Now, one more thing to talk about BCI is FCI is set on September 30th of the fiscal year. So when you see an FCI value, it is of that date. One of the things about BCI is every time you do a roll-up, it calculates a BCI. So if you go in there tomorrow, you might get a different BCI. Your FCI will be stable, but the BCI changes depending on what day you roll up. And Matt, in release 27, could you make BCI be September 30th too? And then it won't jump around. So I might be retired by then, but that's one of my one wish list for you today. So it is possible to have the same BCI and different FCI. So here we go. We have BCI of 69s, but one FCI of an 80 and one FCI of 100. Does that make sense? And of course, you can have the same FCIs and totally different BCIs. Very soon, that upper left is going to have a really bad FCI, but today, it's got an 80 FCI. So that is what we came up with for visualizations on how to try to make it easier to understand what is going on in a building with BCI and FCI. I hope y'all liked it. So now we're going to talk about the other thing that I wanted to know is what combinations of BCI and FCI occur naturally in nature, right? So what do I mean by normal? Well, I think normal is if you had a good asset management plan. So you had business rules because builder doesn't live in a vacuum. And that's one of the biggest things I've learned about being in this conference is that Builder is one piece of software that you configure to work with your business process. And what your business processes are has a great impact on how you should configure and use Builder and your KPIs. So I have to define what the business process is to determine normal. So if I have a business process that's going to look at a building and at a certain point in time make it eligible to fix the building, spend the money, fix the building, right? And then watch it decay again, and then spend money and fix the building. And that's a reasonable approach. will I see which of these 4 different combinations of states am I going to see? So show of hands, and this is the easy one. How many think it's perfectly normal to have a good BCI and a good FCI? Anybody? Okay. Same thing with good FCI, bad BCI, right? All 4 states. We're going to look at each one of these 4 states. Okay, and we're going to look at them using the visuals that we did in the last section. So how are we going to go about this? I'm going to run a simulation that's going to show you a simulation, and we'll see whether or not that simulation gets into each of those 4 states. And then I'm going to go look in real-world data to see if I can find an equivalent building, a real-life building that meets those conditions. Now, for this presentation, again, PRV equals CRV. The max RSL is equal to 0, which let me use a CI less than 40 to determine work. And all buildings have complete inventories. Now, simulations are an asset manager's laboratory, right? This is where you get to play what-if games. This is why Builder has scenarios. You get to go in and try different things to see what works for your business process. So the business rules that I'm setting up for this simulation are: we have an unlimited budget. We will spend the budget in the year after our FCI goes below 80. So in the year we get a bad FCI, that next year we're going to fix everything that's wrong in the building and reset the FCI up to 100. So does that sound like a reasonable thing to do? That if you had the money to do that, was that something you might want to do? So, good. So what is in my simulation? Well, I took a real live 1,000 square foot admin building, and I reset all its components back to an age of 0. And I reset all the components back to the default curve. And I created the appropriate settings, and then I ran a simulation. Now, the simulation produced a plot that looks like this, and plots also take a high cognitive load to understand what's going on in the plots. So what we're going to do is we're going to look at 5 data points on the plot to see what's going on at those points. So the first thing we're going to investigate is good BCI, good FCI. And I chose 2 different years on that plot, year 8 and year 10. And I'll show you why. So year 8, before year 8, we only have green coins. So everything is in the green. But in year 8, we have 3% of the building has deteriorated down into the yellow region. So we've got 3% in yellow and 97% up in green, and a BCI of 96. And there's no red coin, so our FCI is 100. Okay? In year 10, those yellow coins have slid all the way down into red. So now we've got 3% red coins, 97% green, and you can see that that green being further away is influencing the BCI to be a little lower. It was 1 point different between the stack of green coins. Now it's 2. So the green coins are at 94, but my BCI has dropped to a 92. So that is good. So we see that in the simulation. It's there a lot. It happens with every new building starts out in this state. So it was real easy to find a real-world building. So here's a real-world building, and I had hundreds to choose from, and it was very easy to find one to put on this display. So we have a real-world building that's got 16% in the red at a score of 27, 15 at 58, and 69% at an 89, gives us a 74 BCI and an 84 FCI. So we see it normal. Well, that was not unexpected. The other thing that is pretty easy to tell is when both BCI and FCI is bad, right? That's kind of a, yeah, no, of course, we can have bad both. So this happens out in year 40 in the simulation. You can see that the FCI line dips below The FCI line is the red line. It drops below its threshold of 80, which is the red dotted line, and the blue line dropped below 70, which is the blue dotted line, which is the threshold for bad BCI. So both lines at this point in time are lower than their thresholds. So what does that look like in our new plots? This is rather interesting. We have an almost even distribution of sections. I've got almost a third of my building in green, a third of my building in yellow, and a third of my building in red. And having a third of my building in red makes my FCI drop to a 66, and my BCI is a 57, way lower than the 70 threshold. So bad and bad is easy to do in the sim, and unfortunately, we have a lot of buildings in that situation. And actually, if we didn't have a lot of buildings in that situation, we probably wouldn't have a job, right? Because it's our job to try to fix this. So here's a real world building, and you can see it's a 58 and a 50 on the scale. But now, can you have a bad BCI and a good FCI? So we're going to go look at line 34, but if you'll notice that the BCI is bad from about year 32 to year 40 when things get fixed, and FCI is way up there, okay? To me, this makes sense because a section lives a long time in the amber range before it actually fails. So when you look at this point in time, you can see we have really bad, 5% of the building is in really bad shape. It's got a BCI of 6. We got 32% that's in amber, and the green is up there at 69%. So our BCI is low, and our FCI is good because those yellow coins haven't moved on to red yet. So it was easy to find points in the simulation that matched that, and it was also very easy to find things in the real world that are in this condition. So here's a real world building. You can see 15% in the red. Again, there seems to be an avalanche of yellow fixing to come into red and will eventually drive that FCI down. Okay, so I want to show you what that can happen when you're in this situation. So I've taken this building, and at the top is the same plot that was in the previous page. And if I took that 15%, that red coin, and fixed it, it's going to shift the green column. The green column now becomes 49%, and the green column shifts from an 81 to an 86. And our BCI slides, to a 69, which is still failing. So it is possible to have an FCI of 100 and still a failing BCI. So it doesn't happen a lot, but it does happen. I've seen it as high as 10, if you did this in about 10% of your inventory, is the maximum I've seen that can be in this situation. So just know that that can happen. That's all I'm going to say today. So now, the last situation. Can I have a good BCI but a bad FCI? And there was one point in the sim, this point, I can't remember, it's year 20. At this point in the sim, the FCI has dropped below the threshold, but the blue line hasn't got quite to its threshold. And it looks like this in our plots. So we have 27% in red, which 27% gives you an FCI of a 73, only 1% in yellow, and a lot in the green, so we have a BCI of 73. This turns out to be a real unicorn, because I did find a real world building like this. Now, because I set the business rules up, No client of mine has the same business rules that I did. So they all had our max RSLs, not 0, right? The artificial choosing 70 as a threshold was just me picking a number, and I picked it just because everybody's used to red BCIs in Builder. So when I looked at the data in its original state, I had 12 buildings that matched this in one little chunk of buildings that I looked at. When I recalculated the buildings to meet these business rules, like recalculated the FCI and only failed things when the FCI was below with 40, none of those 12 met this criteria. So I started doing a search, and I looked at 7,000 buildings if you count. I looked at the current state and the next 10 years. And of those 7,000 buildings, I found one that currently met this criteria. So this is our unicorn. It can happen in the real world. It's just really rare to happen. So it does exist in the real world. So when I looked at the 4 different possible states of good BCI, good and bad BCI, good and bad FCI, I found that you can have all 4 states in a normal building. So just keep in mind that this was all done under one set of business rules. If you change the replacement threshold on things, if you change what threshold you want for a bad BCI, you have to do this again to see what combinations of those things actually happen. So that's all I got. Questions? I didn't give Joe any plant questions, so somebody else might have to step up. Okay, I think, oh, John's got one.
Okay, John Crittenden, NAVFAC. So on that one plot where you had some requirements, but yet it was like the 20-year. No, maybe right before the 20-year issue. Yeah, that one right there where you have 51% on the bottom. So those are definitely in the range of getting some replace actions, or at least repair actions. And maybe it's the repairs, because the ROI internal to builder is saying, well, let's punt and do a replacement in a future year. Maybe that's where those 53s are coming from, that average of 53.
Well, what I did is, in the sim, I did not do repair work.
Oh, okay.
So I didn't do replace work, and if we had RSLs greater than 0, some of those yellow would be in the red for this building.
I see. Okay, so it was just a business rule. Okay.
It's the business rules, like I
I
said.
worry sometimes about the ROI internal to builder. It's the
Yes.
repair ROI.
Yes.
If it's not greater than 1, then we're not going to do it, and it's going to be a future replacement. That really creates issues, like of builder requirements coming and going. I call it oscillating.
It's caused a lot of issues for me in the past. We actually had a building that had a perfect storm of repair work. So if you guys don't, for those who don't know, as the builder, you go down the curve when you're typically right at the green amber border around an 80, 88 in there. Builder can trigger, depending on your settings, you can trigger repair work in Builder. And so it'll put some work into your work plan. It's 10 to 12% of the CRV of that section. Now, what was bad was one time, happened to us in the DODEA. We had one building that had so much repair work that didn't get fixed that after a couple years, the repair work goes away, and we had a building jump from a Q3 status to a Q2 status by doing nothing, right? And so when you tell the client, well, why did this building jump from a Q3 to a Q2, is because we did nothing. And their response, of course, is, can you do a whole lot more nothing on all my other buildings, right? So one of the things you might want to consider, that if you do not do the refurbishment, that you can set your policies and standards such that no repair work gets generated. Now, if you do take the repair work seriously and you are going to go out and look and see if you want to refurbish that thing, please do. It's cost effective. That's why the ROI calculations in Builder. But if you are so worried about your backlog of things that need to be replaced and you're not doing that work right now, look at your settings, change your minimum CSCI for repair and drop it below 40. You make it 10, make it 1, and then your repair work won't generate anymore. And then so your backlog will be higher, and you won't have to explain how your buildings got better because you did nothing, which was a very awkward conversation. Almost as bad as BCI. So, thanks, John. Good question.
Hey, Steve.
Okay.
You're on the unicorn slide.
Mm-hmm.
Do you think that happened because... Closer to the mic, please. Oh. Yeah. On the unicorn slide, do you think it turned out to be bad FCI or good FCI? What it was, yeah.
Bad FCI, good BCI.
Bad FCI, good
both
BCI.
by the skin of their teeth.
Right, but what impact do you think the PRV had on that? Do you think there was a big delta between what it should have been versus what it is?
No, I actually recalculated the PRV for everything to say PRV equals CRV. So that FCI is an inventory-based FCI.
Okay.
It's when you use, if you're using a DOD facility, your FAT code and the parametric cost of your PRV can wildly change these results. You can have a situation where if everything in your building failed, you still have a good FCI. Or if 5% of your building needs work, you have a bad FCI. So that's why for this scenario, I chose to take PRV out of the equation and just set it to the CRV.
Yeah, okay. Thanks.
Okay, Paul, I think we're done.
All right. Thank you, Steve.
Break.
Yeah, we're a little bit early, so I'm actually okay with that because I enjoy the networking opportunities that we have at this conference. So let's come back at 10:45 for our next session.